Hey guys, welcome back to the shop. So I've got this hydraulic cylinder here that's got some damage and needs a little bit of repair work done to it. And we also need to machine a brand new rod gland for this thing. So this is what was inside the barrel there. And you know, they had to do what they had to do to try to get this thing apart. And unfortunately, this is just a common issue with hydraulic cylinders. A lot of times you get these guys with a lot of age on them. They've been sitting out in the rain and the weather for decades, and they just start kind of growing together. And sometimes this is what happens when you try to unscrew the rod glands or even a cap that might be screwed onto the outside, is that all it takes is just one little fine burr in there to catch, and then it just causes a chain reaction when you're trying to take this stuff apart. So that's what's happened with this. The threads on here are completely galled. And inside the barrel here itself, I know this is a little bit hard to see. We'll see if we can try to get you a nice close-up video of this so you guys can see a little bit more detail. But the aluminum from the rod gland is actually kind of galled to the threads on the inside of the barrel here. So the first thing that we need to do is go ahead and chase these threads on the inside of the tube. Chase them and rethread them so that we have some good threads to work with whenever we go to make our new rod gland. So I think what I'd like to focus on for this video is setting this up in the lathe. We'll have to use a 4-jaw chuck. We're going to have to use a steady rest, and we're going to have to retool this end down here to get it all nice and true, clean those threads up. And then once that's done, we'll come back and then we'll start on the rod gland here. I've got this piece of ductile iron, got it from CRC Distribution, as well as the seals. We got the seals in yesterday, so we've got all of our soft parts in there, all of our seals for the piston, the rod, the O-rings, all that kind of stuff, so that we can actually put this back together whenever we get this rod gland built. So we'll focus on that later. And just for today, we're going to set this up and get these threads cleaned up and get going on it. First thing you got to do is kind of calculate, you know, what the thread is, what the existing thread is. And after doing a little bit of measurement, I realized that this is a 2 11/16 12 thread on the rod gland. A little bit odd size, a little bit of an oddball, but it's actually pretty common to see that in OEM type applications like this. You know, they typically find sort of one of those in between sizes, you know, so that's between 1 5/8 and 1 3/4. You might think that 1 3/4 12 would be a more standard size, and for some applications it is. But some manufacturers like to use some of those in between sizes to make it more of a proprietary piece that you have to go to them to buy. But if you're a machinist or you have good connection with a machine shop and know a good machinist, you can make anything you want. It doesn't matter what size it is. So even if I was just to duplicate this in a 1 11/16, that'd be no problem at all. But what we're going to do is probably go up one size on this rod gland. That is a common thing I've done in the past whenever I worked in the hydraulic shop, is when you have a barrel or any kind of component part that has a galled or damaged thread, is you can usually take this to the next size by 1/16. In our case, if we go up one size, that's going to take it from 1 11/16 up to 1 3/4. So 1/16 difference. That will still allow to have some of the threads in there, but what we'll have to do is pick up on that thread and actually cut it to the proper depth. So we'll get this set up. I need to kind of face this in, get it squared up again. We'll have to counterbore this to what I would consider the tap size, you know, your minor diameter that it needs to be, and then catch the thread, chase it to cut it to the proper size. And then once that's done, this will all be ready to go. And then we can just simply machine a new rod gland with a 1 3/4 12 thread on this piece right there. All right, so it should be a pretty good little project. So we'll go ahead. We're going to use the Precision Matthews lathe for this job to get this done. So I'll meet you over there and we'll start getting the barrel set up. We're going to start setting the lathe up. First thing we need to do is remove the 3-jaw chuck and install the 4-jaw. That's so that we can chuck on the tube that's welded on the end of the barrel. Just got to loosen up the cam locks on the back side here. right, it's already loosened up. And we're going to use our sky hook. This is just what they call the chuck hook right here. So you can easily use it to install and remove any kind of chuck from the machine. Let's see. There's that one there. This chuck wrench is a little bit tall. I got a different one that'll actually work better though. Yeah, it's a little lower profile right there. All right, and then we'll get the jib crane over here to pick it up. Makes it nice and easy to remove those chucks there. We'll go ahead and set this off and I'll bring the forge jaw over. All right, first thing we need to do before we bring the forge jaw in is to go ahead and make sure that our spindle face is clean. Always do this anytime you remove and install another chuck or another accessory. Just make sure that there's absolutely no chips on this. I usually give the spindle nose a good wipe out, and I even wipe out the inside here. Because this is a Morse taper fit in here too. You want to keep these nice and clean as well. Go ahead and wipe the outside. Just, it's easier to clean this off whenever you have the chuck off out of the way. I usually give it a wipe with my hand just to make sure I don't miss any of the dust particles. And I'll do the same thing to the back side of the forge jaw. All right. Like I was saying, you got to clean this too. Make sure that the face of the chuck is completely clean. Clean these studs off. And right up in here where the spindle nose centers up on the chuck, got to make sure you get all those chips out of there. So I'm just going to set it down right here so it's not swinging around. Just about like that. And I'm going to go ahead and clean that well. Spray a little bit of the power lube on here. Kind of break everything up. Because I do, whenever I take these things off, anytime I take a chuck off, I always spray it down with my SP350 rust inhibitor. I always coat everything down with this right here. And then after it sits for a little while, it attracts, you know, you'll have a little bit of dust buildup on it. So you can spray a little bit of penetrant on there to kind of break that loose. And then just wipe it good and clean. I always give it a rub with my finger. Same thing on that face out here. Just want to make sure there's nothing holding that face off, so your chuck will always run nice and true when you put it back on here. These all feel good. All right, I think we're ready to go on there with it. Give it one last check there just to be sure. Everything's looking good. Try to give you guys a little bit better shot of that. So just walk it in nice and gently. You can spin this to align the studs. And work it up in there. Just like that. Take and just snug up one of the cams just to hold it in place, and now we're ready to take it off. This is what we're going to be chucking in our forge jaw, so we just got to get a measurement. So 4 inches long, 1 3/4 diameter. Okay, setting the forge jaw chuck. I usually use a reference, which would either be, in some cases, this edge right here, like where this angle comes and meets the side of the jaw, where it meets up with, see these grooves right here? I use these, and then a reference point on the jaw on all 4 of them. A lot of times what I do is line up this corner out here, like this, this main jaw. So that groove, all right? If you just kind of start them all equal. So I'm gonna back this one out until it's lined up with this groove. Same thing with this one here. That one's lined up good, and that one seems to be lined up good too. I also take note of the orientation of the chuck key or the square drive. Usually what I like is the orientation of the handle being either this direction or that direction, because sometimes whenever you're adjusting these four jaws, what you want to do is like a quarter turn or a half a turn or even one full turn. So I like them to try to start like that, you know, all of them in that direction or that direction, not at an angle. So just a personal preference. What I'm trying to do is talk you guys through what's going through my head whenever I'm adjusting a four jaw chuck and using that. So see, that one was a little bit angled, so we just turned it that way. So now that we got all these matched in this on the same ring right here, let's go ahead and take two jaws 180 degrees apart. So we'll use these two here. Let's go to 4 inches. All right, so we're just under 2 inches right there. So I know we need to move this out 1 inch. And you can just visually do that, or you can count them. A lot of times what I like to do is count it, you know, like 1, 2, 3, 4, 5. I know I got to go more than that, but I'm showing you guys. 1, 2, 3, 4, 5. If you do it equally, it's going to be pretty close to the center. All right, so we still got 7/8 of an inch to go. 2, 3, 4. 1, 2, 3, 4. Let's see how close we are. Right there on 4 inches. All right, see how close that is? So that'll take care of the width of the tube we're chucking. Now we need the 1 3/4. So we really only need, you know, 1/4 of an inch. So for this one, you can go 1/2 turn in, 1/2 turn in, and we're right there on 1 3/4. So if you want to give an approximate, 1/2 turn is approximately about 1/8 of an inch every time you move that. So that should be pretty good there. Now, to make your life a little bit easier when you come in here with it, in case this is a little bit too small and you have to loosen them up, get the jaw where you want it, okay? And then take the top jaw and the one in front of you back like a 1/2 a turn. So we're gonna move this one out 1/2 a turn, move that one out 1/2 a turn. That's going to be your clearance, so you can swing your piece in here and you tighten these two jaws. All right, so we'll go ahead and grab the barrel and bring it over here. First, I think we need to get the steady rest set up first, though, before we put it in there. All right, next up, since we want to bring our steady rest in here, I want to take and I want to wipe these ways off here where the steady rest is going to sit, so that you're not clamping down on chips. It's about like that right there. And I've already measured the tube. It's going to be approximately somewhere around 22 inches or so where we're going to be at. So something about like that right there. And you can just use your finger and just kind of, you can make you like a little witness mark like that right there. So when you bring the steady rest in, you can just set it there and you're in an approximate location. Not that you can't easily slide it, but just when you're working with like the big heavy steady rest, like on the American Pacemaker, and you're using a bridge crane to bring these things in, you kind of want to get them set down close to where you want them instead of having to slide them up or down the machine somewhere. So that's what I meant by marking your location. This is a small, lightweight steady rest, so it's no problem just to set it down and move it where you want to. Thing's been sitting down there underneath the jib crane getting kind of dirty. I'm going to gently set it down here, and I want to make sure that the bottom of the steady rest is clean as well, just like that. No chips or dust underneath it. And set it in place. Sometimes these things you gotta do that. You gotta take them all the way down just to get these clamps. So you gotta slide it anyway. Some of them got enough clearance where you can just rotate them out the way, and then sometimes they don't. All right, so somewhere about right in there is where we're going to want it. All right, and then loosen the set screws there so we can bring these things on down some. So what we'll end up doing is using a bell center to support the end of the tube out here. We'll have it, trued up on this end. We're probably going to skin that tube round so that we have a nice true journal for these rollers to roll on. Okay, before we go put this in the lathe, we're going to have to do just a little bit of work on this outer end right here. So it looks like whenever they were using their pipe wrench to take that gland out, they got down into the barrel here and it's really just kind of pushed this material over. There's a nice heavy edge right there that's going to throw it off if you just go stick your center in it like that. There's also one over there. So I'm just going to take a carbide burr and just dress this so that it takes the high spots down off that outer edge of the bevel. After cleaning it out with the wire brush, I can see a lot more of the thread in there, and it's still rough, but it's possible we may be able to just chase this and get that aluminum out of the threads. You can see it right there. There's some aluminum stuck in that particular thread and then going around, but you can see just how worn the threads are from corrosion. And there's some more there at the bottom. You can see the aluminum stuck in there. So what we may do is just go ahead and see about chasing these threads first, just to see how they look cleaned up. And if they still look questionable and not really sure, then we can definitely go ahead and bore it and rethread it to the next size up. But I think for now, we'll just go ahead and start with chasing them and see if we can get them cleaned up. All right, it's time to get our barrel in the lathe here. Got our 4-jaw chuck set good here. Got that in a good position. Going to be a little tricky to indicate, but we'll get it. We'll go ahead and we'll get a live center pushed in there. So I've got this newer TMX live center that's got the interchangeable tips, and this bell center actually fits that pretty nicely. It goes up in there. After I ground it, I realized it actually is going to kind of clear that little edge that I was trying to grind off of there. But let's get it in there and show you what I'm talking about. So it should be pushing, on that machine bevel in there instead of out here on this messed up edge. All right. So we need to get this in running true, what I'll do is just we'll put an indicator on here. We can't go all the way around because of this tube in the way. This is your hydraulic line, but we can start here and just go around like so. We can go all the way around to that point right there. So let's get this end indicated. It's pretty good. It's not too far off. I'm going to move it over just a little bit more. All right, so we can start there. We can just kind of reference that as our 0 point. You go 180 degrees backwards. So that's off, 5 thousandths. That's not bad at all. Tighten your highs, loosen your lows. 4 and 5. It's going to move a little bit. Get that another snug. Now we're going to go to this one. So that's like -11. And then we'll have to go to this side here. And that's plus. So this one's high. Let's go ahead and snug it first. So there's your low. Loosen your low. Oh, we got to go the other way. Tighten your high. So that's about on a 5 plus 5 and about a 0. So we're almost there. Three and 2. So that's looking good. 2 and 2. Now let's go back to this one. Where's this one at? 3 and 2. So this one we can snug it up. We're basically true. So I'm happy with that where it's at. I'm going to go ahead and just snug these again. That's at the top. You can get more torque on it up here on the top side. Make sure that they're all good and tight. That's looking good. Go here. So that's going to be well within, I'd say a couple thousandths of being true. So we're going to leave that right where it's at. And that should be running good right there. On our steady rest end, I actually want to skin an area that, tool it, machine it down so that we have a nice true spot. I measured this and it's egg-shaped. You don't want to roll something on an egg-shaped OD if you're trying to clean the ID up. It's going to be elliptical just like the outside. So we're going to go ahead and just move this on down here out of the way just to get it out of the way. And I got to back these rollers back so that we clear this hydraulic tube here. Yeah, that's clearing it nice. And then we go ahead, just for safety, just snug the clamp here so that it doesn't get bumped and moved accidentally. So it's nice and rigid there. All right, and then now we can put our tool in there and skin this in true. Once we get this trued up here, we'll bring our steady rest back here, get it set, and then we move the live center back out of the way. We'll go ahead and see what it's looking like spinning first. Go to medium, about 250 RPM. Okay, that's looking good. Everything's looking good. All right. Use our turning tool. All right, let's just get this cleaned up. Tell you what I'll do first. Let's just go ahead and get us a stop established on here. So I think we'll go somewhere to about right there is good. I'm going to 0 the Z on the DRO. We just want to clean it up. Start with 10 thousandths. Let's see what that does. We'll just make that pass and let's see what it looks like. our 0. All right, and that's normal to see that off center like that. That's gone through a lot of abuse trying to get it apart, and it may not be, whenever this ID is honed and even machined, it's not always exactly true with the OD of the tube. That's why when you build a lot of hydraulic cylinders, you have to set it up like this, machine some undercuts for your steady rest to ride on, set your steady rest, and then go in there and do the ID machining. So we'll take another 10 thousandths. This is not hurting the structural integrity of the tube either, taking 20 thousandths off of that. I've read a lot of those comments throughout the years, people saying that you just weakened it and that's a failure point. That's not true. It's normal practice with building hydraulics is to machine the OD true so that you can get it true with the ID. We've almost got it here. We might be able to run the steady rest on part of this. I'm going to go ahead and set me a 0, back my tool off. Almost. We need a little bit more. I don't know if the, see, you got a little spot there. If the roller's rolling here, it's going to be kind of getting into that. I'd feel better if we took just a little bit more right there. Maybe even 5 thousandths. Let's try that. Speed it up to 380. It'll help if you put it all the way in gear, not just partially. There we go. Okay. Go into our 0 plus 5. I think that's the magic number right there. 25 thousandths total. That cleaned it up. See, sometimes all it takes is another 5 thou and you got it. Okay, so what we'll do next is go ahead and get our steady rest down here. So we need to clean the chips, get the chips out of the way. And let's go ahead and set our steady rest. Put it in neutral, which it is, and then you just want to check everything. So as you're getting the steady rest set, you have to make sure everything's clearing. So, you know, the material here, the housing that's holding that ball bearing, you want to make sure that this hydraulic tube doesn't hit that. So we'll get it up there really close to it, and I'm going to roll this around to where it's next to it. And I just want to be a little bit further away. I think that's going to be good right there. I'm going to go ahead and bring this back one up. And I'm just going to roll it by hand. Make sure everything's clearing. I think that's going to be pretty good right there. So I'm going to go ahead and bring the top jaw down. I think that's going to be a pretty good position there. We'll go ahead and lock the bottom clamp in place. Okay, so now what I want to do is go ahead, we're going to turn it on. We'll slow it down a little bit more. Bring it back to our 180. All right, and now this is when you want to bring your steady rest up. Very gently, kind of like you're using a micrometer. You don't want to force it on there. I usually just really light fingertip touch to the knob here, and the bearing is rolling now. And I just ever so slightly, just any kind of slack that's in the bearing, I'm just trying to get it pushed away, okay? I'm gonna reach behind, don't reach over the top of your workpiece over here. Reach behind the machine and bring this one up. Same thing, bring it up where it's touching there. Just ever so gently, just try to get any kind of slack out of it. Now it's ready to go. You can bring your top one down. It's touching. and we're good to go. So we're going to go ahead and loosen the quill lock on the tailstock. I'm going to back this out with the handle here. And hopefully that ID is running nice and true to that OD now. So there we have our tube now set up in the steady rest. We should be ready to roll. Right now I'm working on getting the bar set up that we're going to be using to chase this thread. So I've decided I'm going to go with my Aloris boring bar here that takes a 5/16 tool bit. So I'm going to have to grind this into a threading tool, which is something that I need to do anyway, have one of these set up and ready to go. But the reason why I'm going this route versus using a carbide insert tool is because of the interruption that you're going to be making in here. You know, cutting out aluminum and the interrupted cut, you're liable to chip the insert. This is an example. This is a really good tool that I have. This is the Micro 100, one of the Micro Quick bars that I have, and this is for threading. This would be an excellent tool to go in there and cut these threads with, but I don't want to risk breaking this tool. This is expensive to buy, and I'd rather use an inexpensive piece of high-speed steel that I've had that I can just grind into a tool just to chase those threads out. So if you're doing stuff like this, the high speed and the cobalt tools is actually a better option, just so you don't risk breaking your carbide. So that's the route that I'm going to be taking on this job here. So I do need to go and grind this into a threading tool, so that's up next. Over on the pedestal grinder, it's going to show you the tools that we're going to use to start with. So we've got this is a piece of Momax. All right, and I want to make sure that one edge is exactly 30 degrees off this side. We want to make sure the tool is in line straight. It's not, you know, ground on a weird angle or something. So we've got the Starrett number 19 protractor here that we'll use to go ahead and get one side ground on the 30 degrees. And then we'll go in with the number C391, often called a fishtail or a thread gauge, and we'll use that to make sure that we have the other side ground to exactly 30 degrees for a 60 degree included angle. All right, so let's get started on it. Just work one side. I am on the coarse wheel, by the way. Just do a little grinding and cooling in the dip bucket there. And no, this does not mean that you have to re-harden the tool bit. It's another comment that you see often is people are unaware. They think because you heat this up that you have to go through another heat treat. High-speed steel is not designed that way. You can get this red hot and it still has the same hardness to it. You get most of the grinding done over on the coarse side here and then move over to the fine side just to touch it up. So I'm just going to be referencing my number 19 protractor to get that angle about as exact as I can, and well, it looks like I'm right on it right there. That is really, really close. So I got to step back and hold this up to the light to actually see it, and we're close enough that I can dress that on the fine side to get it exactly where I want. So I'm going to go ahead and come over here to this side. Now I'm using the fishtail thread gauge. Just get it roughed in, get it really close, and then we come back and touch it up as we need to. A little bit more on the back end. A little bit more on the back end of the tool needs to come down. All right, that's looking pretty good. I got to hold it up to the light where I can see past it. That's looking pretty good. So from here, we're going to take our tool and come over here to the fine side, and we're going to touch it up there and finish it out. I'm going to come back to the first side that I started with. I know it's a little bit dark over here. I apologize about that. I really need a work light just hanging right over this, and I have never gotten one set up. I had just a little bit on that back corner that I needed to grind away. So I'm going to hold it up here to my gauge in the light. And that side looks beautiful right there. So we're at 30 degrees on what you're looking at, the right side of the tool right there. So now we just need to go back to our thread gauge here and grind the other side so that we have a good 60 degree included angle. So I can tell that I got to grind a little bit here on this side. Checking in the light so I can see it. Yep. You guys are into grinding your own tool bits like this, it's good to have a dedicated pedestal grinder with wheels that you only use for tool steel like this. I never grind anything else over here other than tool bits. Occasionally I might hit it, you know, with a bolt or something just to deburr something, but never come over to the grinder that you're using to grind tools, to grind soft steel, you know, regular maintenance type stuff, because you're just gonna ruin your wheel and create problems. So I'm just touching it up so that we can get it to fit in our thread gauge there as perfect as we can. I got to keep looking up into the light. We are almost there. I mean, it is just so close. A little bit on that back side, just ever so gently, and that is looking beautiful right there. That looks good. I've got it matched up really nicely to our thread gauge there. So all we really need left to do, we need to break. It doesn't need to come to a sharp point. So what I usually do is just barely touch it there on the wheel, and then I'm going to use a stone and actually kind of hone that where it's a little bit round right on the tip of it. Don't need much, just break it off, just like that. A little tiny flat on the end of that, all right? And I'm gonna check this off camera just to make sure I have it right, and then we'll go over there and set this up in the lathe. But our thread tool is just about ready to go. Got one of my honing sticks right here. We're gonna go ahead and hone that tip. This is just how I do it right here. Doesn't have to be perfect. I'm just trying to get a little bit of a radius on the nose of the tool right there. All right, and then we're gonna do the same thing on the side. You know, it's got a nice grind, but it does even better if you hone that. If you was to zoom in on that with a microscope, you would see all these little scallops in the side there. So you take you a good hone, an oil stone, whatever you got, and lay it flat on that edge that you ground, and just rub it. And what you're looking for is that top edge to slick out. You'll see a nice hone pattern all the way across once you have it there. That side looks good. And we'll come over here to this side, same thing. Push it down flat against the edge you ground. That's looking good. Toning out nicely. Just keep working it like that until you can see all the way across that edge that you've got it honed. I'm going to do the same thing with the top. Now, some people might ask, well, why didn't you grind any back relief in that? You know, some back rake. It works fine at a neutral rake just like this. It works better if you have a little back or side rake, but I'm not wanting to jeopardize the geometry of the tool there. We're just chasing a thread. So I'm just keeping it as a neutral rake. So we're just going to slick the top of the tool there. Just get it kind of polished, get rid of that discoloration. Like that. Now I'm going to go over to the fine side. This is that white. It's actually white there. It's just a polishing stone is all it is. I'm going to take that side and just polish both cutting edges. Polish the radius on the end of the tool a little bit. And then the same thing with the top. So now we've got a nice tool that is ready to go and thread. I can do some double checking with my thread gauge here. You have to get rid of the dust. You'll get a little dust down inside the V of the tool there as well. You match it up. That is looking good. Really good there. Same thing with the protractor. just matching up really, really nice. So anyway, there's our thread tool. You can continue and do a little refining. In fact, what I'm probably gonna have to do, give it a little bit of relief on the bottom right here, because this may, as it's coming in into that bore, it'll probably hit the bottom. So when you're on the inside, you got to make sure you have clearance on the bottom. So I'm just going to go touch that up on the grinder to get rid of some of that on the bottom there. And we may not even need to cut this thing, but typically what you do is take it and just cut it to the length that you need. All right. Here's a little better close-up shot of our tool that we just finished grinding. I just put the bottom relief in there, and you can see the hone on the cutting edge sides. Hone on the top. Turned out nice. And I'll see if I can show this here as well. Let's see if I don't make myself look like an idiot, because I called it getting ground on a nice 60-degree angle, and it looks like it is. So there you go. Should be good to go. The tool is a little bit too long to go in. I mean, it would work, but it doesn't give you a lot of clearance. So I'm going to go ahead and just take this guy and just basically just cut it in half, and that'll give us another tool bit in the box to grind later on. All right, there's our cut-off tool bit. Go ahead and get it in the bar here and tightened up, and we can start getting to our thread chasing now. All right, so before we start lining up that thread, I do want to go in there with our thread pitch gauge here and just double check it. I've already checked it once, but I want to double check it. So yes, that is a 12 pitch. That's what we're going to be cutting. So I just wanted to verify that again before we set up our lathe. Before we go in there and line up our threading tool, I want to make sure that that bore is round, that I don't have any high spots sticking up out of those threads. So I'm going to run this boring bar through here and just clean it up, maybe touch off somewhere and take about 5 thousandths, 10 max. I'm checking the top pressure of my steady rest here, making sure I'm down, and I am. The very back end of the threads are the best in the best shape, so I'm going to use those. There's our touch off right there. All right, so let me just take about 5 thousandths on this. All right, there's the back. I'm gonna do a Z0 position right there. And in fact, I'm gonna go ahead and put my dial indicator over here because it's just easier to see looking down here at this dial. Okay. It's a little bit off center, a few thou, so we're not cutting all the way around. I can tell, well, it is pretty close. That very last thread, I can tell that the tool is touching all the way around there. Just for good measure, I'm going to go another 5 thousandths. Another 5, so 10 thou total. That should clean it up, hopefully. There it is, X0 the tool. All right, well, we did what I wanted. We cleaned up the tops of the threads there. So we'll go ahead and pull the boring bar out and we'll put our threading tool in there. All right, now we can start getting our tool bit lined up. First thing I want to do is establish this indicator for our position where we're going to stop, disengage our threads. So this is a little bit hard to share on video. Let me see if I can get a little better angle there. But I got to get in here with my flashlight, and kind of what I want to do is bring this tool in, and I'm just trying to line it up by sight at the back end there. And it looks like I'm lining up in that thread right there. I just want to kind of get the tool in position on that very last thread so I know where to disengage. So I'm going to set my indicator over here to make sure I'm on the right 0. I want to set a 0 over here. And this is the one. Now that's going to change slightly as we line up the thread, but it's okay. That tells me that we're really, really close there. All right, so we'll back out and come on out of there. All right, and we need to get the lathe set up, cutting 12 threads per inch now. Over here on our quick change, we want 12 threads per inch, LBT6V, LBT6 and V. We should be cutting 12 threads per inch. All right, let's see if we can get her lined up. I will try to get y'all a better close-up of this once we get rolling, but for now I just got to get everything set up and going our way. So 12 threads per inch, we should be able to engage it anywhere we want on the threading dial. It shouldn't matter. 4 thread per inch lead screw. 12 is divisible by 4, so you can engage it anywhere you want. So we're going to go ahead and engage it. What I'm going to do is stop it. Just use the foot pedal there. And we're going to stop it. Probably have to go in there just a little bit further. What I want to do is try to get to a clean thread. That's the main thing. And I'm going to use the cross slide. This is working pretty good actually. So what I want to do, we are utilizing the cross slide. I'm sorry, the compound slide. I want this, if you're looking at the tool, the left side of the tool to touch that thread, that side of the thread. And then once we get that side of the tool touching the thread, then we can simply use the cross slide to bring the tool back to the very bottom of the thread. So I'm actually going to go forward with the compound because I can't tell if it's too far to the right side. That's looking pretty good. So I'm just walking it in with the cross slide nice and gentle. I'm not trying to pull any hard pressure on it, and it stopped right there. So what I'm going to do is go ahead, I'm going to set this collar to 0. I'm going to 0 out my DRO as well, and then we're going to take the compound, which is set, it's set on 29.5 degrees, so it's not perfect, but it's plenty close enough for doing this. And I'm going to go ahead and bring this tool back at the angle until I feel it just bottom out in the thread. Sometimes you got to do it a few times just to make sure that you're not over tightening it. So somewhere about right there is the bottom of the thread. That tool should be pretty well lined up in the center and to the very root of the thread there. All right. So now I'm going to center up, or I'm going to 0 out this collar as well. Let's see if we can find where this is the only one I don't really care for because it takes you have to use an Allen wrench to loosen this up. And I don't really like that. There we go, there's that 0'd out. And if I bring it that way with the compound slide and I come back, where it wants to stop is on 0. I can check this as well, cross slide, bring it straight back, bring it back in. You can hear the 0 approach beeping at me. And it's actually about 5,000 shy, so I'm going to go ahead and reset this to right there, just in case I pulled on it a little bit too hard. And we technically should be lined up with our thread right there. So at this point is where we back the tool out, disengage the half nuts, and bring it on out. And now we can start chasing our thread. Now I don't go all the way to the bottom. I sneak up on it. So you go somewhere out, you know, a pretty good distance away, and engage it and let it go through there and see how it does, and just keep bringing the tool to you until you get to that 0, or when you can see that the threads are fully cleaned up. Okay, so we'll start 80 thousandths off of our 0 and see how that does. Got it engaged, and it's going to hit that aluminum right there. All right, I just backed it out that way on my 0, and it looks like we're lined up pretty good right there. I heard it just touch the backside. Disengage the half nuts, and you can bring it on out. I think we did pretty good right there. So I was on 80. So now we'll come to 70, and I'll just take 10 thousandths every time until we start seeing it cleaning up where it needs to be. Just like that. It's not taking much. Really all it's doing is it's cutting that aluminum right now. All right, so let's keep doing that. Let's see if we can get you a better video. We're getting pretty close, but we still got about 20 thousandths to go, so we'll just keep sneaking up on it. That's 10 thousandths off. That looks like it's starting to clean it up pretty good all the way around. It's almost there. I think a few more thou and we're going to have that thread cleaned up. Taking 2 thousandths a pass right here. That's giving us 4 thousandths off of our 0. That's looking real nice. Guys, I'm happy with the way those threads look. I don't see a need to go ahead and bore them and rethread them to the 2 3/4 size that I first mentioned in the early part of the video, since this tool has cleaned up all those threads minus the areas where it was too corroded to clean up. All we need to do is just go in there with a buffing wheel to polish those and soften all the edges, because if you run your finger in there now, you can kind of feel a little bit of burrs here and there, especially where the corrosion is. But I'm going to leave it like it is and not worry about changing the thread. Only thing left we need to do, it'd be nice to kind of clean this face up just a little bit, clean that up right. But I'll get a buffing wheel so we can go in there and just kind of polish this out a little bit. You want those threads to be soft. You don't want anything sticking out for it to gall next time you go back together with it. Here is a polishing wheel that I've got ground to fit a standard V-thread, and this is the one that I'm going to use to try to polish, go in there and polish the rest of the thread and polish where we chased it there, get rid of any burrs. Here plugs in. Well, this guy right here keeps kind of catching. I'm trying to get it in a position where it doesn't catch on me. Yeah, that feels good. Feels nice. All right, I think we're gonna be good right there. I am going to give the lathe a good wipe down. That is abrasive material that we just used. Just trying to address in the comments. I will take and wipe all this off before we do anything else and make sure that all that abrasive material is up off the ways and things like that. But our threads are looking good. Let's just need to face this outer face there and get it trued up. All right, last step. Let's just clean that face up. I already wiped the ways down, by the way. You might hear some chips hit those rollers. That's okay. I'm just doing this by hand. I really just want to make sure that we've got a square face there for the gland to pull up to. And we're just about there. I'm going to take just a little bit more. I haven't even measured it. We're just cleaning it up. All right. This part is not cleaned up, but we're not going to get it all cleaned up because of how chewed up this is. Over here on this side, you'd be taking a good 50, 60 thousandths off of it to clean that up. Swapped out our tool. Let's put a little chamfer on that outside edge. There, the chip finally hit it right at the end. All right, I think we are technically done with what we wanted to do with this thread here. We're going to go ahead and take it out of the machine. I think our job is finished up here. I feel good about the threads. When I first went into this, I thought that the threads were a lot more damaged than what originally was there. After we cleaned it up, we can see that there still was quite a bit of good thread in there. So that should work just fine for what we're doing. So we're going to call this completed. We're going to take it out and move on to the next phase of the rebuild. All right, guys, well, that is going to wrap up the machining for this video. I'm going to consider this part completed. So next up, we need to go ahead and machine the new rod gland right here. So we've got that piece of 3-inch ductile that we're going to be machining that out of. So next video, we'll take care of this right here. One last thing that we do have to do as well is press the pin out of this rod end right there. So this, I've got my presses at the home shop, so that's where I'll be doing this. And you know, probably grab the camera and show that there as well. So anyway, I hope to see you on the next video where we'll get our new rod gland machine to fit the threads of the barrel.